All right, so this is where things are going to get very interesting. We have now defined the concept of TCPs, of planes, and variable waypoints, what these poses are. So now we're going to walk through different examples about how to move relative to the base, move relative to a plane, relative to the tool, and how to get the position in a given plane. So we will sort of solidify all these concepts through an example. All right, so now we're going to discuss all the details about moving in these using variable waypoints and all the different methods that we described earlier. So the first one we want to do is we want to say, okay, we want to move relative to the base. So we're just assuming here that we have a plane defined as it is here. This is our origin. It's called sketch rotation, and it has our x-axis along the orange line, the green line defines the y, and the z defines our z. And the blue defines our z. Okay, so the first thing we do is, let's say we want to move relative to the base, right? So we come in here, we're going to move at 100, we're going to move at 100 millimeters per second with a certain acceleration. Okay, so I'm just going to move the robot up. I'm using the joystick here in the background, but so the robot is up. So the first thing we do is if we move L and we say relative to the base, right, what waypoint can we use? So we can choose as our waypoint actually our plane. And if we do that, then what's going to happen is that we will move to the origin of the plane, because this plane relative to the base is exactly where, the origin of the plane. So just to show that, we're going to move there. So we move right to the origin of the plane. All right. So now we're going to say that we have a point that we assigned this point to have a 25 millimeter offset in the X and a 25 millimeter offset in the Y. So now that is going to be the bottom left corner of that first blue rectangle. So if we want to move to that point now, how would we do that? We would come here to the move L, and we would come here to the plane that is called sketch rotated. And now, instead of moving to the sketch rotated plane, we want to move to the variable P1, right? So if we move to this offset relative to that sketch plane, we are going to move to that corner of the rectangle. Okay? So now what would happen if we actually say that we want to move now relative to the tool? So in here, we come and we say we want to move relative to the tool. If you remembered, we set up the tool to have this same orientation. So if we move P1 relative to the tool now, right, we are going to move in the XY from our current position. So we will hit the corner of the center of the rectangle. So if I do it, we are now at the center of the rectangle. And I can actually do that again, right? And it's going to be relative to my current position. So because it's my current position of the tool, so I will go actually to the corner. So that is the power of these variable waypoints and understanding if you want to move relative to the base, the tool, or a frame. So now let's look at what happens in script code in which we have a little bit more power on what we can do here. So let's suppress this and let's look at the set of instructions here. All I'm doing is just, showing a way that you can set your TCP. You can say set no action and set it this way. So you can programmatically change your TCP as you go. So here, right? So I'm going to suppress these other moves so that I can show you how we're going to do sort of similar things here. Okay, so the first one, right? We're moving L and we're moving relative to the base. So move L, whatever pose, right? Whatever pose I put here, which is in this case is the sketch, is going to move relative to the base. So if I do that, I will hit the origin of the plane. This is the equivalent to that first example where I showed moving relative to the base. So let's do that and show that. As a matter of fact, perfectly, we are getting exactly to the origin of the plane. So now, how do we move relative to a plane? Well, what that move L is doing in the background when you choose a different feature than the base, it is essentially doing this. It is saying that you want to translate the pose P1, right, which we have defined as 25 millimeters X, 25 millimeters Y. We're going to transpose that relative to the sketch frame, to the sketch plane, in this case called sketch rotated. So now if we do that, now we're going to move again to the corner there of the rectangle. All right, very good. So how would it work to move relative to the tool, right? And so the way you would move relative to the tool is actually over here. And the way it works is it looks exactly identical, right, to that first step, that previous step. But what I'm doing now is I'm saying, instead of choosing a plane, I'm choosing get actual TCP pose, right? Get actual TCP pose is the current frame of the tool. So that is almost as if you were to have a plane defined at the current position of the tool. So I'm doing that, and how am I translating that pose? I'm translating it by a certain height called APR. And APR here, I'm defining it as 100 millimeters. So this is another sort of trick that makes things easier to read. You can define here APR as 100 over 1000. So it's easier to know that you are going 100 millimeters. So when I move with this, I am now going to move 100 millimeters from the current position of the pose, of the tool, sorry. So I do that and I move up exactly 100 millimeters. At any point here, you can check your actual position by going to the Move tab, and you can see that I am at 25, 25, and 100. And then relative to the base, relative to the tool, obviously I'm at 0, and relative to the base, I'm at, whatever the offset of the plane is, and so on. So again, that is how you move relative to the base, the tool, or a plane. So how do you actually get the position that you have in that plane? Well, so let's say now we turn this off, so we're not moving, and I say get actual TCP position. So if I call here get actual TCP pose and I assign that to a variable called base position, if I play this, if I say play here, I can actually come into here, into the variables, and I can see my base position is actually the position of, it's some position that is not what I was expecting relative to my plane. This is the position relative to the base. So in order to get the position relative to a particular plane, you have to do this command, which is that you are transposing the actual position relative to the inverse of whatever plane you want to get the position in. So in this case, we want to get the position relative to the sketch rotation plane. So if we do here now play, and we go to variables, we now have a sketch plane position here that's a plane position here that is 25, 25, and 100, essentially. And so that is how we can get the position relative to a plane. All right, so another very interesting thing that you can do now, and I'll just show this a second here. So let me suppress this back and suppress this back here. So now let's say I have a certain orientation, and let's say I want to approach, let's say I want to come at this point at, some sort of tilt so that I can, do a dispensing path. So let's unsuppress here this orientation. And if we have here our axis, right, the way that the rotation works is that you have to put your thumb in the direction of the axis, and then curling towards your thumb like that is a positive rotation. So if we actually want this to be tilted like this, it is a negative rotation in the y-axis. So that's why we're going to put minus 25 degrees here, and we're going to set this point here, right, to have that rotation for the y. So this is our ry here. So we go variable, orientation. So now what would happen if we approach this plane now? So if I do this and I unsuppress this, and so we move relative to that plane to P1, you're going to see, right, that we're going to go to that corner of the rectangle, and we are going to come up and we're going to be at a tilt of 25 degrees. So this is really nice because now if you'd want to do a different tilt, right, through all of your different, poses, you can just dial it in here and you can say, you know what, 25 maybe is too steep. I want to do 20. And you run that and you'll be at 20. And so one typical thing also that once you have this tilt, you may want to pull out, right, relative to that tilt. You don't want to pull up straight up because if you have something that's interfering here, you're going to hit the sidewall. So how do you pull up relative to this current position? Well, that is exactly what this moving relative to the actual tool does. So if I unsuppress this guy now, right, what I'm doing is from this current position, I am going to be coming up by my approach of 100 millimeters. So if I run this now, I will go up, but I will go up in that tilt following the tilt of my tool, right? And again, I can change this. So with one single parameter, right, I can say 25 degrees. And now if I play this, you'll see that I'll come up at 25 degrees and go up at 25 degrees. So again, come in and come out at the tilt that I've defined. And that is extremely powerful, and you will see how that will help us as we build our scalable path following projects.